I welcome you all to this session on blockchain development training. Okay, so let's begin with today's session. Now let me quickly give you all an overview of the topics that we're going to cover today. We'll be discussing about blockchain and the concepts that make its foundation. Then we'll talk about the blockchain related employment opportunities and the technical skills that you require to grab these opportunities. We also will be giving a little special attention to smart contracts and smart contract development, since it has become such an integral role of a blockchain developer. I'll also show you some really interesting smart contracts and decentralized applications that have been made so far. And in the end, we're going to have a code along session where we make our own very own smart contract to simulate Kickstarter in a decentralized manner. Now, it's almost taken for granted that you might know what a blockchain is when you're attending a blockchain development training session. But for the few of us amongst us that still don't know or have a few doubts, I'm going to be going over the basics of the technology that has had quite an impact on the world. So, blockchain is the technology that serves as the backbone of cryptocurrencies. In short, blockchain could be described as an immutable record of who owns what. But what does that exactly mean on a computer? On a computer, it would mean it is a decentralized and distributed database of ledgers which are synced across a peer-to-peer network through a consensus algorithm. That might have confused some of you, but fret not, everything will be clear by the end of the session. To get a better understanding of blockchain technology, let us go through its four main concepts. The first and most principal concept of blockchain technology is distributed and decentralized networks. So unlike centralized networks that are owned by a company or an organization and are a focus of data, decentralized networks are the exact opposite. Decentralized networks have no single point of functionality. They have multiple servers over the network that hold these pieces of data that is being transferred through the network. It is because of this design structure that attacks like DDoS, which are focused on specific servers, are rendered useless by a decentralized network. A decentralized network can be compared to a light bulb with more than one input wires. Even if one stops working, the light bulb keeps glowing as long as one of those input wires are working. The second concept of blockchain technology is that of a shared ledger. A ledger is the list of transactions on the blockchain network. Now, every time any peer on the network commits a transaction, it is broadcasted to the entire network. If the network's consensus algorithm deems the transaction valid, it is added to the ledger. The catch here is that the ledger seen by any peer is the same as they are kept in sync. The ledgers serve as a single source of truth for transaction history. Now that I've told you about the consensus algorithm, it's only fair we discuss it, as it is the third principal concept that keeps blockchain technology up and running. The consensus algorithm allows a peer to come to the decision whether a transaction is valid or not. A consensus algorithm can be thought of as a complex math problem. This problem is solved by miners or anybody on the network. Okay, so coming back to the topic of consensus algorithms, there are many types of consensus algorithms. The first consensus to be ever used was proof of work algorithm, which was used in the Bitcoin blockchain. Since then, other concepts of consensus algorithms have been invented, for example, proof of stake, proof of elapsed time, proof of capacity, and proof of storage. These consensus algorithms serve as the heart of the whole system, as it is the singular thing that tells us about the validity of a transaction. The last principal concept of blockchain technology is cryptography. Cryptography is the art of hiding and encrypting data, or in more technical terms, transfer a given plain text to its respective ciphertext. Blockchain uses state-of-the-art cryptographic algorithms that result in such a secure and immutable system. The most prominent form of cryptography that can be seen is public-private key cryptography, which is mainly used to generate unique digital signatures for every transaction. The sender of the message uses his public key in conjunction with his message to form a ciphertext. Since the digital signature is made in conjunction with the message, it ensures that the digital signature will be unique almost every time. Cryptography also secures other aspects of blockchain technology, but that's for some other session, some other day. So now that we've discussed the principal concepts of blockchain technology, it must make more sense to you when I say that blockchain is a cryptographically protected, universally synchronized, distributed, and decentralized database of who owns what. It's quite a revolutionary thought process that has been implemented into this fantastic piece of tech. This also means that blockchain technology has created numerous job opportunities for tech enthusiasts. Let's discuss these job profiles now. So as you can see, there are three distinct job profiles, namely a blockchain architect, a blockchain software developer, and a blockchain consultant. A blockchain consultant is a person who works as any other consultant and advises organizations and businesses as to how blockchain could help their cause. Next, a blockchain architect, as the name suggests, is the guy responsible for building blockchain architecture and protocols regarding blockchain networks. Next, we have blockchain software developers, or commonly known as blockchain developers. These people are developers who develop applications using blockchain technology. As some of you guys attending this session might already know, that decentralized applications have become quite the buzzword in the tech community, and for good reason too. These decentralized applications have zero downtime and complete transparency and security, which is quite a lot to offer for an application. This is exactly what blockchain developers are busy coding. So since our topic of the session is blockchain development, we'll be discussing about these guys a little bit more. So let's begin by discussing the technical skills you guys need if you want to become a blockchain developer yourself. First of all, you need to have a very good understanding of cryptography and data structures, as they form the base of blockchain technology. Next, you will have to study the blockchain architecture. And the best way to do this is by reading the Bitcoin white paper. As Bitcoin was the first implementation of blockchain, its white paper has the working of the same down to the tiniest detail. Also, you guys need to know some basic web development to become a practicing blockchain developer. Last but not the least, and also the most important requirement, is the ability to develop smart contracts. So for those of you here that have no clue about smart contracts, these are pieces of code that can help control blockchain transactions. A very simple example would be something like a transaction that is controlled by a test condition. For example, a smart contract could exist that sends some amount to Prerna or Shashank here on the outcome of some football match like Manchester City versus Manchester United. Smart contract functionality is available on various blockchain platforms in today's time. So let's go through a few of them. The first platform that comes to mind when talking about smart contracts has to be Ethereum. Ethereum is the first blockchain platform to implement smart contract functionality. Built by Vitalik Buterin, Ethereum advertises itself as a robust peer-to-peer network that works like the world's supercomputer by connecting peers across the globe and helping them commit transactions that have more value to them than simple bookkeeping of values. Next, we have Hyperledger. Hyperledger is a project under the Linux Foundation that strives to bring blockchain solutions to industries and hence create a blockchain network that supports true private and confidential transactions. Next up, we have IOTA, which uses a special technology called Tangle. As the Internet of Things keep expanding, the need for interoperability and sharing of resources has become a necessity. IOTA enables companies to explore new business-to-business models by making every technological resource a potential service to be traded on an open market in real time with no fees at all. Lastly, we have Stellar. Stellar is a platform that connects banks, payment systems, and people. Stellar integrates all these components to move money quickly, reliably, and at almost no cost whatsoever. Okay, so now that we've seen who developed these decentralized applications running on smart contracts, it's time I show you some of my personal favorite decentralized applications. So firstly, we have Lazoos. Lazoos is a decentralized taxi service that connects drivers directly to customers. In this way, they remove centralized services like Uber and Ola, which take away a maximum margin of the profit by paying the drivers only minimum wages. Next up, we have Leroy. Leroy is a decentralized Twitter. Our online identity and data is particularly sensitive, and data breaches by centralized companies like Facebook, MySpace, Microsoft has made us realize how vulnerable we are. Leroy takes all this data and stores it on a decentralized network such that nobody owns your data for future misuse. Pretty cool, right? Lastly, we have Slockit. Slockit combines the two most promising technologies, that is blockchain and IoT. With Slockit, smart apartments become fully automated, smart objects can be rented on demand, and unused vehicles get a new lease on life. They are developing the future infrastructure of sharing the economy. Now, all these cool, decentralized applications have one thing in common. Their basic application logic is run with the help of smart contracts. Okay, so I guess it's time I give you all a demo on how to build a smart contracts ourselves. So we're going to be trying to solve a problem caused by centralized services. So in today's world, a great idea isn't enough for building businesses. You need proper planning, a revised business model, and most importantly, some handsome funding. Now, unless you're some rich guy, funding is always a problem for projects, and this is where centralized services like Kickstarter come into the picture. These fundraising companies have some general problem caused due to their inordinate power they hold due to centralization. Some of these problems include things like anyone who misses out on a deadline for the campaign cannot get in, or donors who change their mind about the project that they've donated to can't get out. The whole process of providing a project with a little bit of funding has been contrived by the unnecessary rules of Kickstarter. So we're going to approach this problem the decentralized way. The person looking for funding will submit their project idea on the blockchain network for funding. This project will be issued a certain token which can be given to anyone who wishes to donate money to the project. This token can be sold by donating person at a later time if the project generates profit, or if he expects that the project will fail, he can just hold on and just move away from his losses. This way of issuing a token gives the donating party some control over the money, which was not prevalent in the centralized architecture of Kickstarter. Okay, so let's begin coding. I'm going to develop this contract in Solidity, which is Ethereum's major smart contract scripting language. We'll be also using the Remix browser. So let's head over to the Remix browser first. Yeah, I already have it open, but you can always visit it by going to remix.ethereum.org. So press the plus button out here and create a new contract. So I'm going to be naming this contract crowdfunding. Hit OK, and there we go. So let's remove this first. Yeah. So we're going to do this the decentralized way and just create a token to keep track of rewards. Anyone who contributes gets a token and they can trade, sell, or keep for later. When the time comes to give the physical reward, the producer only needs to exchange the token for real products. Donors get to keep their token even if the project doesn't achieve its goal as a souvenir. So it's going to be like a winner-takes-all crowdfunding contract. So we're going to create the contract with minimum entry fee for the project. The project will have a proposal deadline and a campaign deadline. Before the project proposal deadline, people can enter their projects providing a name, a URL, and the entry fee. When the project proposal deadline is over, people can vote with Ether for the project they want to support. So our contract architecture is going to be something like this. We're going to have a minimum entry fee for a project to avoid spam. Then we are going to have a project proposal deadline and a campaign deadline. Before the project proposal deadline, people can enter the projects providing a name, a URL, and an entry fee. When the project proposal deadline is over, people can vote with Ether for the projects they want to support. When the campaign deadline is over, all the pledged money, including the entry fees, goes to the project with the highest votes, and the contract is closed thereafter. So let's begin. So I'm going to name my contract Winner Takes All. So this is how we define our contract. It's like defining the class statement in other languages. So we're going to have some state variables. So let me define them first before I go ahead and explain them. So uint minimum entry fee, uint public deadline of projects, uint public deadline campaign, uint public winning funds, uint public winning funds, address public, we're going to call it winning address. So we've defined some state variables for our contract here, where we will save the initial parameters with the project is in the lead and how much money it has pledged to it. Some of these have public modifiers, which mean that we can access them from the outside. This way we can display the deadlines and the current winner in our UI. So next we're going to create a structure. A structure is something similar to the structures in C language. So let me just write my code before I explain it again. Struct project. So our project will have an address. It's going to have a name, a URL, the amount of funds it's generated, and a flag to know whether it's initialized or not. Oh, I forgot to tell you all that we have to specify the compiler version, and we do that by saying pragma solidity anything above 0.4.17. So out here, I'll explain what I've done. Solidity provides us with the ability to create user-defined structures called structs. So while we can only use these inside our contracts, they're still useful to organize our data. In this case, we create a structure for a proposed project. So now we need to keep track of all the state changes within our contract. To keep track of state changes within our contract, example, a user pledging money to a project, we also create a so-called mapping. These mappings are like hash maps in other languages, but have some limitations, like they're not iterable, for example. So let's create our mapping first. So we will go mapping address, and we'll map it to the project. And we're going to call this mapping projects. So I made a mistake here. This is equal to. Next up, we will create the address array and call it project addresses. Next up, we need a counter for the number of projects. So we go public number of projects. So Solidity doesn't let us expose these mappings to the public. So we also track at least the addresses of these proposed projects in the address array to be able to query info about the proposed projects from the UI. Another limitation is that these arrays, even if they are public, are a bit bothersome to query. So we also have this counter called number of projects, so we know how many projects are proposed at any time in any point. Next, we need to create some events. So event project submitted, and this is going to take a number of parameters like the address, ADDR, and we're going to give it the string name, the URL, and the boolean of whether it's initialized or not. Next, we need an event in the case projects get supported. So project supported, address, ADDR, event amount, and event paid out to. So this is also take an address and the amount of winning funds. So let me explain what I've done. These events are only used for debugging purposes in our contract. We can basically use them to log onto the blockchain, which can be helpful when testing and debugging the contract. We can also listen to these events using web3.js, which is a framework for interacting between UI and the contracts. In this case, we create an event for all our transactions as well for all the finishing of a contract. So now that we're through with all our state variables and events, we get to our functions. The function is the constructor, which is the transaction with which the contract is created. In this case, we supply the two deadlines as well as the minimum entry fee we want to set. So let's get on doing that. So we go function winner takes all. So since this function has the same name as our contract, it will be called when the contract is created, as it's the constructor function. So it'll take a uint of minimum entry fee and the uint of the duration of projects, and the uint duration campaign. This function should be public, and let's begin building our logic. So if the duration of the campaign is less than or equal to the duration of projects, then we simply throw. Now if minimum entry fee, now we just set it up. So minimum entry fee equals to minimum entry fee. So deadline projects will be equal to now plus duration. So now plus duration projects plus. So now plus duration of projects. We don't need anything else. So deadline campaign will be equals to now plus duration campaign. Then the winning address. So the winning address will be message.sender, and the winning funds are just set to 0 by default. Yeah, so it seems we're doing correctly. So let me explain what I've done. This function is the constructor, which is the transaction with which the contract is created. In this case, we supply the two deadlines as well as the minimum entry fee we want to set. As you can see, Solidity provides a nice API for handling dates with the now keyword, as well as the possibility to add and subtract time units from it. If the campaign deadline is before the proposal deadline, we throw, which is basically Solidity's way of throwing an error. This means that the whole transaction is cancelled at this point and all funds are rolled back to the previous state. Okay, so now with our constructed contract in place, it's time to submit our first project proposal. We do this with the submit project function. So let me create everything before I go ahead and explain it all again. So we go function submit project string name, and we give the string of URL. So we're going to make this function payable, public, and it'll return the boolean value. It's called success. So go if message.sender is less than the minimum entry fee. Message.sender, not the sender, we need the value. So message.value, we're going to throw. Next, if now is greater than deadline of projects. Then also we'll need to throw, because he's definitely crossed the deadline. And if project message.sender initialized, if it's not initialized, we're gonna initialize it. So projects message.sender equals to project message.sender name, URL, initialize 0, true. And we're gonna push this to the project addresses. So yep, dot push message.sender. Now we also need to increase our number of projects. So number of projects equals to project addresses dot length. Next, we need to get the project submitted thing. So we're gonna pass it message.sender name, URL, then projects, and then we'll return true. Else we have to return false. So let me explain what I've done. So first of all, you should notice that the use of the payable modifier. This means that we have access to the message.value and the message.sender variables, which are the address of the transaction sender and the money they send. We check if the message.value is above a specified minimum entry fee, and if it's not, we throw, cancelling the transaction. We also throw if the proposal deadline lies in the past. Then we check if there is already a project from the sending address with the initialized flag. Unfortunately, there is no way to check whether a mapping already includes a key or not, because it is automatically initialized with every possible key. So we must do it this way. If the project is from a new address, we create a project and add it to the mapping, as well as our address array list, and trigger a project submitted event. So now we'll do something else. We're going to see how we can actually support the project. So we're going to build the logic for that. So now let's create a function called support project. Function support project, and we'll give this the address addr. Make it payable because you're going to pay this guy something, and it returns boolean of success. So if message.value less than equals to 0, we'll throw, because who really actually just donates nothing? That just makes no sense. Throws. So if now is more than the deadline, or now is less than equal to the deadline of projects, we're going to throw again, because it makes no sense if you've crossed your deadline. Next, if the project is not initialized, we have to check that condition too. Project. So if it's not initialized, we're going to throw it, because we need our project to be initialized to be actually funding it. Now, if it's passed all these tests, we'll do projects addr dot funds plus equals to how much ever this guy sends. So message dot value. Next, we'll see that we create some events. So let me just explain what I've done a bit for those who couldn't catch up. So Solidity doesn't let us expose these mappings to the public. So we've added the funds of the project. Now we're going to check something else. So if project addr is the address funds are greater than the winning funds, then we just set the winner. So winning funds equals to project. So we've given them the funds of the winning funds that we've set up, and the winning address also has to be set. So winning address equals to addr. Next, we have to call the event project supported. So project supported will take in the address, the name, not the name, just the message.value, right? Yeah, the message.value. Next, we just return true, that it's successful. So let me explain what I've done again. Now that we have projects, we can pledge some money to them. That is, if the proposal deadline hasn't run out already, or we are still before the campaign deadline. The function is also payable, so we again have access to the message.value, which is the amount of money pledged to the project. We check the deadlines, whether the pledged value is a positive number, and if there is even a project with the given address. If any of this fails, we throw and cancel the transaction. If everything goes well, we increase the project's funds and update the winning project, also triggering the project supported event for debugging. So now for our UI to be able to display the available projects, which we need to do, because it would be quite hard for a user if they can't get any infos about it or the addresses to send the money to, we also provide a get project info function. So let's get on creating that. So function get project info, and it'll take the address, addr. It'll be a constant thing, so public constant returns string name, string URL, and the amount of funds it's collected. So we're going to define a variable called project, and it's going to have the project that we are querying. Next, if the project isn't initialized, we're going to throw else. We're going to return project dot name. Okay, so remember, as I stated above, we can't return structs yet, but what we can do is return multiple values from one function, which is exactly what we've done here. We have accessed the name, URL, and funds through the dot operator through the project variable. So also notice the constant modifier, which means that this function doesn't modify the state of the blockchain and therefore doesn't cost any gas. Now we need to finish our project. So let's go and put up a finishing function. So function finish. If now is greater than equals to deadline campaign, and we're going to call the event paid out to, and we're going to pass in the winning address and the winning funds. Next, we're going to self-destruct. So this is a pre-made function that I'm going to explain later. So self-destruct winning address, and we're done. Let's see, function finish. This finishes the function and this finishes the contract. So let me explain. All right, let's say people propose some projects and we also have some people pledging money to those projects. What happens then? Optimally, we would automatically end the contract once the campaign deadline is over. However, this is not an easy task to do. We would have to trigger it based on some time, like a cron job. Now there are solutions for this out there, such as this. But in our case, we will create a finish function, which must be called at some point after the deadline is over by the winner, for example. If the deadline is not over, we just don't do anything. If it is, however, over, we basically just trigger an event called self-destruct with the winning address. The self-destruct is a built-in function which closes the contract and pays all the money in it to the given address. So this ends our winner-takes-all crowdfunding contract. So looking at me actually develop this smart contract, it must be pretty flustering as you all don't know much about this language, I guess. So to actually learn blockchain and smart contract development, you need a structured learning and roadmap. At Edureka, through our blockchain course, we give you a very structured and modular way to learn the technology. So Edureka is an e-learning company that has live instructor-led sessions. At Edureka, we also have a 24/7 support team that is there to guide you through your technical and non-technical issues regarding your course. Once you sign up for a batch at Edureka, you get a lifetime access to the learning management system that has all your documents, your PDFs, your projects regarding your course, and that can be seen by you in a very structured way. Following which, you can also reassign your batch if you think you're not comfortable with the timing. Also, if you're not understanding the course through a single go-through, you can always sign up for future batches at free of costs. So that's it from me today. I hope you all learned something through this session. Goodbye.